Welcome to part 3 of the video on limits are infinity. In this third part we're going to solve limits with radicals, that is, limits that have square roots. And our first example is this one. The limit as x approaches infinity of the square root of x squared plus 1 over x plus 1. And here the trick is to do something similar to our basic technique that we learned in part 1. That is, we divide and multiply by x squared, but only inside the radical. That is, we do this. Here we divide by x squared and we multiply by x squared. We take x squared because here we have x squared. So we can write this factor like this. And now we have to consider two different cases. The first one is when x is negative. And we need to remember that when we use this square root sign, we're taking it as a function, and we're considering only the positive square root. So the square root of x squared, in this case, as x is negative, the positive square root of x squared is minus x. Because x is negative, then minus x is positive. So what we did here is to take the square root of x squared and take it out here. And we can write this also as minus. We can take the minus sign out of the limit sign and take the x here below here in the denominator. And now we can write this denominator as this. And now we're taking the limit when x approaches infinity, but we're only considering x positive. And that is x negative. So we're taking the limit when x is approaching minus infinity. Here it should be minus, not plus. So we're taking the limit when x approaches minus infinity. And this 1 over x squared will approach 0, and this 1 over x will also approach 0. So this will be the square root of 1 over 1, and minus that's minus 1. Now we're going to consider the second case, that is when x is positive. When x is positive, remember that we had this expression, this original expression. And when x is positive, the square root of x squared is x. Now we do the same trick that we did before. We take the x here down below the denominator. We write the denominator like this, and we take the limit. This will approach 0, this will approach 0, and now we get 1 positive. So the answer to this problem is the limit is 1 when x approaches positive infinity, and the limit is minus 1 when x approaches negative infinity. And we can check this with the graph of this function. You can see that when x is taking values greater and greater but positive, we see that the graph of the function approaches 1. And when x becomes negative and approaches negative infinity, the function approaches minus 1. So you can see that what we did solving the limit makes sense. Let's solve another example. The limit as x approaches infinity of this difference between two square roots. Now what we can do here is to divide and multiply by the conjugate. The conjugate is the same expression, but instead of the minus sign we put the plus sign here, and we multiply and divide. Doing the algebra in the numerator, we had that if we multiply these two factors, we get this difference of squares. That's why we also multiply by the conjugate, because when you multiply these two conjugates, you get the difference of squares. Now we have the square root of something squared. The square root disappears and you get x squared plus 1 minus x squared minus 1. That's plus 1. So here these two x squareds cancel and we get 2 in the numerator. Now we see that here we have x approaching infinity, so x squared will also approach infinity, and this square root will also approach infinity, and the same with this other square root. So we have two terms that approach infinity. The sum also approaches infinity, and we know that when we have something, a fixed number divided by something that approaches infinity, the quotient will approach 0. So we have that this limit equals 0. That's the answer. So that's all for now. Thank you for watching and see you next time.